Mateu is setting up the environment. Okay. Sorry. Okay. Just a brief about them. Probably you already know them. They are Christian López Espínola, Mateu Aguiló. Mateu comes from Mallorca. He works for Lulabot, and Christian López comes from Seville and works for Lingotech. They are going to speak about how to do PHP test in Drupal 8. So in my opinion, this is a very important session. So for making our projects more sustainable in the at the end, I'm going to make a job probably. So okay. What else? Are you ready? Okay.
Yes.
So
Yes.
please have a strong applause for them.
Buen día. Egunon. Buenos días. Buenos días. Good morning. We're going to use this thing. I don't know if you've been in another presentation with this. This is a kind of cool way to interact with the presentation. It allows you to take notes that are private to you. It will give you a link to download the presentation with the notes, with your own notes at the end. And it also gives you the opportunity to ask good questions at the end. Yeah, there's also likes in the slides. If you like a slide, you can click a like. Should be like a select box that you can show. Okay, yeah, sorry. Yeah, it kind of does that. So yeah, I need to set up this. Also, we're gonna ask you some questions using this. So if you set this up, it's gonna be cool, I guess. Okay, so yeah, unit testing in Drupal. This is a very important topic because Drupal needs to be a high quality piece of software, because we've been getting some criticism in the past, and there has been a big switch in the approach. We're doing a lot of OOP these days, and this allows us to finally do unit testing. But before we get into that, Christian is going to introduce me.
So here is Mateo. Please, an applause for him. And he loves quality code, and he's a really awesome swing dancer. And you can find him at E0, Ipso.
You all know Christian, and he likes his code to have full coverage, full test coverage, just like he hugs you, full test coverage. And yeah, let's go into the session. So one of the first questions that you have when you want to do testing is, what do you actually test? Because I don't know if you know this, but there are different types of tests in Drupal core. Apart from these tests, there are other things that can be built on top of Drupal core to do testing. So we're gonna focus on this guy here, on unit test, but there's also kernel test, which is pretty close to unit test with some extra stuff. And then there's simple test and JavaScript test. Simple test has been there for quite some time. There was a contrib module for simple test in Drupal 6 that got promoted into core in Drupal 7, and we still have it in Drupal 8 because it has its use case. And JavaScript test is something kind of new that Daniel Werner explained the first day of the DrupalCamp at the first session. If you haven't seen that session, just go and watch the video because it's really cool. So when do you use one or the other? If you want to do some testing for the business logic of a class, so you want to test that the if that you're doing is actually doing that thing in that method, you use unit test. Why? Because it's blazing fast. You execute the test and you're done. I mean, it goes either red or green, but it's very fast. For kernel test, kernel test has the use case of doing unit test, but injecting some dependencies. So unit test is for testing PHP code. Kernel test is for testing PHP code in Drupal. Like you can have some modules enabled, you can maybe create a node and test interactions with that node, and you can do some stuff. So kernel test adds some dependencies from the Drupal system into your testing. Then there's simple test. Simple test is creating a fake Drupal environment, a fully installed fake Drupal environment, and it lets you execute some stuff and then test the output of Drupal itself. So you're not testing the PHP code, you're testing the full output. And for JavaScript tests, go and watch the video. So a note of comparison is that you want to do a lot of unit tests because they are very fast, even though the complexity is high. So what do I mean by complexity here? So when you are writing a test, you need to set a context, because normally your code works by setting a set of conditions. In this scenario, my code behaves in this way. Setting this context can be a little bit trickier in unit test than in simple test. So you can see that kernel kind of lives in the middle of the other two. When it comes to stability, what I mean here is that when you are developing, when you are actively implementing a feature, unit tests tend to change a lot because you change your code, you're testing your PHP code, and then you need to change your tests. So bear that in mind when you're choosing one or the other, but the important one for me is the reliability. The reliability means how much you can trust your test, right? Because as you can imagine, with the simple test, since there are many things that happen and you're testing the output, you only control the input and the output, you may get some false positives in the middle. So they are all very important. You need them all if you want to write quality code, and hopefully you want to write quality code. If you want to write crappy code, you can just go out, right? Because testing is not for you. So can you go to your phones and respond to this question? Do you know what unit testing is? Have you done unit testing in the past? And I'm going to show the response. And hopefully, many of you will know. All right, keeps changing, but more than half people know what. All right. Okay. I should have seen that coming. It's winning. Okay. So, since apparently half of you don't know what unit testing is, it's basically unit testing. By unit, it means that you're testing units of code, chunks of PHP that you want to assert or check how that code is behaving. But for the part of testing is this assertion. Asserting means that you check that if you subtract all the money and then check the balance account, the balance of the account, you make sure that equals 0. That part, make sure that equals 0, is an assertion. Testing is all about assertions, making sure that given the right conditions, you get the right output or the right changes in state. Because sometimes you don't want to get an output, but you want to set something or a property in a class, and you want to make sure that that worked. So I've been talking about classes all the time, and you may be wondering, what about procedural code? We've been writing Drupal 7 code for a long time now. So what do you do then? You have to know that procedural code cannot be tested with unit test. Why? Well, there are many reasons, but it's because you cannot mock procedural code. And you can test procedural code with simple test, but simple test has its use cases. You shouldn't force using simple test because of the way that you wrote the code, right? So you can write it in classes, then use procedural code. And not only that, but the procedural code is contagious. It's like this kid that is sick and goes to the school, right? And everyone gets sick. You can't have testable code that invokes procedural code inside of it. So even if you have a class, if one of the methods calls a procedural function, you cannot test that method. Okay, so use as little procedural code as possible. But you may say, what about hooks? We still have hooks, and those are procedural code. How? What? How? Right? So the trick, and what I believe is going to become the best practice, is that you're gonna create a service, and that service will instantiate a class. And then from the hook, you're gonna write very simple code that doesn't need to be tested. And I'm air quoting for the video because everything needs to be tested. But simple enough code that it doesn't make you want to die inside because you're not testing it. That is very simple, and then you can use the concept of dependency injection, because in your procedural code, you're creating a class, and then that class can be tested using dependency injection. So what's dependency injection? And this is very big, has a planet and a rocket on it, because it's a very big, very important concept. So if you go out of this session and remember nothing, that would be very sad. But if you only remember one thing, it should be dependency injection is very important for testing. So what is it? Dependency injection. Do you guys know about it? I'm loving this one. Oh, nice. I actually expected less people knowing about dependency injection. It's a tricky concept. To explain dependency injection, let me go back and talk about how do you test hooks. In this case, there's a hook. It's entity create, the hook entity create, and you want to react to my entity was just created, and you get the entity as a parameter, and what you do is you create, or you call the service my module.entity manager. That is a name that I just made up. It doesn't have to be dot something or my module. It's just a string. It's just that I like this way of structuring my services. That is my module.entity manager is the name of the service. And then on there, since that returns a class, then I call a method. And my method is post create alter. I just named the method that. So that's all the hook does. So if you open a .module file and you see a lot of code, you have to suspect that the test coverage is not going to be very high. So .module files are going to be very small because they contain hooks that only call services. So the code, where is the code? The code is in the service. How do you declare a service? You go to your mymodule.services.yaml and declare the same string that you give there and say, okay, this is the class that I want you to use. So we've gone from the hook to a class through a service. And this is where you say which class that service uses, right? The part of dependency injection that I was telling about is here. So in here, I'm saying that my class needs to interact with entities, right? And to interact with entities, there's another service that's called Entity Type Manager. That's provided by core. By using this arguments thing, what we are making is in the constructor of the class, we are passing the type manager and the logger. And we save this here and we're done. With that, we've done dependency injection. It's that simple. So again, if you have to remember something, remember that doing the dependency injection is going to make your class testable. So in here, in my post-create alter method, I can use the entity type manager and the logger and etc. etc. So this is going to do something. This post-create alter is going to do something with the objects that it depends on, right? The cool part is that when you're testing, you don't want to use the whole Drupal to have this entity type manager. What you want to do is pass a fake object, an object that simulates being an entity type manager that behaves in the way that you want. So, inject your dependencies to replace them later. So during test time, you can't have a whole Drupal because that makes it slow and less dependable. You want your dependencies to do what you want. You don't want to, if you need an entity that behaves in some way, you don't want to create the entity that when it does this, then that happens. You don't want to care about that. You want to create your dependency in a way that you control what it gives you, right? And those fake objects are called stubs or mocks. And Christian is going to talk about that. But before, let's kind of rewind a little bit and go back to the types of testing that we have. I was reading about Mike Cohn in Martin Fowler's blog, and he was saying that your testing pyramid wants more unit tests. I said that you want all the types of tests, right? But you want more unit tests than integration tests, right? So the base of the pyramid is unit tests. You want a lot of them, because if you have a failure in the high-level test, that means that it got passed through the unit test layer. So you need to fix it there and there, right? So unit tests for the win.
So how to write these unit tests? So as we see, this is a quote from Albert Camus: "To know oneself, one should assert oneself." So what we need to do is asserting that the conditions we are expecting are having the consequences we want. And for that, we have a lot of assert methods in our unit test case class that we are going to implement in our test. And these methods can assert Boolean values, you can assert identity, you can assert that two values are the same reference, you can assert for a null or a not null, or you can assert for array, you can assert with array operations for knowing if an array contains or not one value or not. And you have a lot of asserts. If you use a proper IDE like PHP Storm, you just type this assert and then you have a full list. And this is, if you've been in my talk yesterday, I said that the most used pattern in software is copy pasting. This is the second one. Is writing an arrow and control a space and see what is in there. So we've talked that the most important thing you should take from this session is dependency injection. And the second big thing is what a mock is. So when we are creating unit tests, what we want to test is how an object interacts with the environment. And because we want them to test only a unit of code, what we do is testing the interaction between the different objects. And these different objects are the object we are testing and a mock, which is like a fake object that we don't really want to test. What we want to see is if a proper method has been called, in which order has been called, and if it returns the value we expect. So by creating these mocks that we can force to return a value, we can test all the edge case without testing the dependency itself, but only the unit under test. So it's like a puzzle. Here we want to test the green piece there, and it's connected to other 4. But what we want to really test is those connections, not the full piece, right? So for that, for creating these mocks, we have in Drupal core 2 libraries now. One is the mock system in PHP unit itself, and the other one is a library called Prophecy. So for PHP unit, you can do something like this. This basic step is you are creating an object that you declare that implements some interface, that is the interface we are injecting into the unit and the test. And we say that we are expecting that any call to the method get with those params will return a given value. And in the case that we want to have we are calling that method multiple times, we can say a map that when anytime this method is called, it will return, if this is the argument that it gets, it will return this value. But if this is the argument it gets, it will return this other value. So this is with PHP unit. With the Prophecy library, it's similar, but as you can see, it's less verbose, so it's easier to read, and it's actually the same. So you have like magic methods, and you can say that the get method with those parameters will return that value, and the same with multiple calls. You don't have you have the same, like you pass the argument you can say the argument you are passing and the return value it will have.
So one thing that that is really cool with this is that when you execute these chunks of code, what you get back is an object that can be used in place of the real object that you want. So when I was talking about replacing, this is how you create the replacement, and then you use this other thing. So this object that gets created, though, doesn't have all the methods that are in the original object. It only has the get method. But that's cool, because you know that the thing that you're testing, it only uses the get method, right? If you want to add more methods, you just do the same. That's it. And you take this object that it returns, either with a PHP unit or Prophecy, and you put it instead of your dependency.
So why, if we already had the PHP unit mocks, why did we introduce Prophecy there in Drupal core? The reasons are quite several. The first one that you can probably see already is that it's more readable, it's easier to read. And another thing is that It was suspended. Some ads. This session is a sponsor, so we have some ads. We'll come back in 30 seconds.
You can keep
Yeah, so the difference, another of the reasons that we use prophecy instead of the PHP unit mocks is that you don't really assert the method you are calling. So in PHP unit mocks, like you are watching all the calls to those methods, but in the case of prophecy, you don't do it unless you want to. So if you are creating a mock and you are saying that it will call a method and will return a value, and because of whatever which reason, it's not called, but you only care about the return value of that code because it's reused somewhere else, you can just assert on that return value and you don't, like the output of your tests will be cleaner, but the way it will be probably more performant because you don't need to watch every method call in this fake object. Well, another thing, right now most tests on Drupal core are using the PHP unit mocks, but there is an initiative of converting most of them to prophecy. So if you want to contribute to Drupal core, it's one way of getting started is working on these kind of issues, and it's a great way of knowing the process of contributing to Drupal 8, so you will feel great. So another thing is data providers. So what you usually, when you are testing your code, you probably want to test all the edge cases, and probably you are creating duplicated code in your test. Like you are testing that if you pass null, it will happen something, but if you pass another value, you expect another output. So data providers allow you to avoid duplication in your tests, and you can just create your test method, which will assert on whatever you are testing, and you can use a notation there called data provider, where you say the method that it's returning the values your test will get, and which is the expected output with those values. So this way you can pass like this is 2 methods, but actually 6 different tests. So we are going to share some tricks that we learned from experience. And one of it is testing code that deals with procedural code. So Drupal 8 is really awesome. I'm sure you will agree, but it's not perfect. So we still have some procedural code in Drupal that it's not used in any server. So you don't have the same, you cannot execute the same code by using a service that you can inject. So if you are creating a country module or your custom modules, and you need to call those methods, as Mateu said, you cannot, if you are using only one of those, you cannot unit test your class. So one way you can do that, you can solve that, is just create a service in your module that calls this Drupal core functional method, inject that service into your class, and then you can mock that one, and you can create unit tests. And the thing is that if you do that, you probably want to contribute it to Drupal core for making it better for other people. So we say that this talk is about unit testing, but we are also introducing a bit about kernel testing. Kernel testing, it's, as Mateu said, in unit testing you are testing a unit of code, generally it's a class, but kernel kernel testing allows you to test APIs, and it allows you to test your code inside Drupal on how it relates to Drupal. So the difference between kernel testing and the old simple test is that in kernel testing you can install modules, you can install your configuration objects, but you don't have access to the database. So you don't really create a database. So it's not as fast as unit test, but it's faster enough than simple test.
Actually, one cool thing about kernel test is that you usually don't have to have a database, but you can have one. So it's kind of you keep adding dependencies on the fly. It's not like simple test that you have to install a complete Drupal site. So it's way faster. You just pick and choose whatever you need. So when do you need to run your tests? Because we've been talking about writing tests, and they need to be green because we want to assert the quality of code. And what good are your tests if you're not running them? So one of the strategies is you develop your feature, you write some tests, see that your tests are making the feature work, and then you merge the code. And someone, hopefully, before merging, someone reviews the code and does all that quality assurance process. So that's what we've been doing for a long time. That's what you do with the old simple test. But having unit testing core now lets you do it in the test-driven development style. So what that is you create a test that fails because there is no feature that implements that test. So you want to implement something. First, you create a test, then you implement the code that gives you that feature until it gets green, and then you send it to review and merge. That is actually what I like to call the fast lane for getting a Drupal core patch integrated in. What is the fast lane to getting a patch in Drupal code merged really fast? Because you submit a first patch with a test of something that should work, right? It's a bug. You submit a test of something that should work. It turns back red, and then you submit another patch that fixes Drupal core and makes that test green. So doing TDD is really awesome, especially when you're in that phase of the project where you already developed most of the functionality and you're dealing with bugs. That is really cool. And now with unit testing in Drupal core, you can do it. Finally, it's like it's 2004 for Drupal. So if you have a CI tool like Travis or whatever CI tool that you have, it's probably a good idea to put it there. This is a setup that I like a lot. Before I can do any commits, even in my local, when I'm developing, automatically runs a process that links my code, that checks that it has the best practices for the Drupal style guide, that checks that I don't have duplicated references, etc., etc. That's PHP-CS that runs that. So I don't commit anything, even in my local, that is not a good code. Another thing that I do is that before I push anything to send to my coworkers to review, I run all the tests. But I don't run them, actually. When I do git push, they get run. And if they turn back red, git push doesn't send the code. So I make sure that I don't waste anyone's time on code that does not pass tests, right? So hopefully that helps everyone to be more productive and again have more quality on the code. It's a little bit restrictive, and sometimes you want to shortcut that because you want to share a branch that it's not really working, but you can pick it from there, right? Those kind of scenarios. You can run git push no verify and it won't run the tests. But yeah, every time you do that, a kitten dies somewhere. So please don't. And finally, in your pull request, if you use GitHub or you use Bitbucket, in there you can have something like Travis that checks all the tests again that they are green because it's integrated with other code. And when that gets green, you can click the merge button. So as you can see, you can integrate that with your workflow to be a little bit unobtrusive, and you make sure that those tests get run a lot. And believe me that that will catch a lot of bugs early in your process.
Some tools for doing the continuous integration with your Drupal code is actually you are working on a country module or a module that you can disclosure to all your fellows. Is using Drupal.org itself. Drupal.org itself now have new test bots that you can configure with different sets of versions of PHP, MySQL, and branch that you are working with. And you can configure when you want to run those tests, which in most cases you want to run it in every issue. So if you are using patch-based process, you want to that every time someone uploads a patch to your issue, those tests are run against your branch with that patch, and you want to be sure that you don't break anything. So you also want to check everything on commit too.
Also, going to this screen or the automated tests tab, it's a great way to see if you can actually rely on a module. If it has a lot of tests, like the Lingotech module has, you can be sure that it's not something that's going to break your site eventually, right?
If your tests are not buggy. So another tool for that is Travis, which is quite often used in GitHub projects. And how you configure that is that you have there's a site which is travis.ci, of course, and you can configure how you want to build your environment, like downloading Drupal.org and downloading and running Composer update and running Composer install, and then you run the test itself in the script section, and you just call PHP unit. This example is taken from the rules module. If you didn't party long enough yesterday, you maybe have been at the session this morning at 9:30, and they have a really good script for running Travis tests and a good coverage. So it's one example that you can reuse if you are working on, if you want to rely on Travis for running your tests.
Also, there is an initiative called it's Fabian Francis scripts that is an integration between Drupal and Travis that does some of this, and it works really great in most of cases. But if you want to go the safe route, this snippet of code, this is something that is known that you just copy and paste and put in your module, and it just works.
And another tool is Jenkins, which you can install in your server, and is what actually the testbot at Drupal.org are using under the hood. And you can configure the scripts like in Travis. You can probably use something similar and copy paste from there. So and just switch the name of your module.
So again, please don't use procedural code. It's random. This slide is randomly put here just to remind you that you don't have to use procedural code, you have to do dependency injection. So that's basically it. So the conclusions are that do testing, because that ensures the quality of your code. You have to care about dependency injection, and you have to mock your dependencies in order to do the actual test. So these three are very related one to the other. You cannot test things without doing dependency injection, and dependency injection is useless if you don't use mocks. And finally, run your tests. Find a way to integrate running your tests with your workflow. Whatever your workflow is, there's a way to make sure that you force yourself and the others to run the tests and check that everything is green. So that's it. You can clap, yeah, please. So I'm gonna check the questions, okay? That didn't go well the other 3 times. Okay, so there are 3 questions. Peñasquito, Swinglands, want to Rapsing. Oh, okay. So there are.
I won. So I have 2 trolls and you only have 1, or what?
So there are actual questions for this. If you don't have questions, I will start talking about test coverage. So you better have questions. Do you guys know about test coverage? Yeah? Some of you do. So test coverage is when you have unit tests. What you can do is track the lines of code that were run when your tests were executed. So basically, if you go back to your editor, for instance, to your PHP Storm, you can actually see all the lines of code that are being covered by tests. So you see there that there is a gap, and this chunk of code is not being tested. So that's also pretty cool. And it's a very good challenge to make sure that you have 100% test coverage. And if you see that, if you do that, you have 100% test coverage, you go and put yourself a medal, because that's really hard and that's really impressive. Questions? The last one gets a hug from Peñasquito and a high five from me.
100% coverage hug.
All right then, I guess that's DrupalCamp.
Yeah, thank you.